Okay, good afternoon. We'll go ahead and get started with the last presentation for the afternoon. So my name is David Berzik. I'm the construction robotics lead with Trimble, and I'm excited to be back at Digital Construction Week this year to talk about robotics and construction. To give you a quick overview before we dive into the customer case study that we have with Mace Group, I want to just provide an overview of the solution and how it's being used out in the construction market. Back in October of 2020, Boston Dynamics and Trimble got together and we made an announcement about how we wanted to bring construction robotics into the construction market for doing data collection. And we announced back in October of 2020 this vision of how we saw robotics coming into the construction market. We saw it as being these fully autonomous robots that are working collaboratively with humans on the job site. So we refer to these as cobots, where the robots are there to really supplement the teams on site and not necessarily replace the teams on site. It's really a supplement to help address labor shortages. And that these robots that are being used on the job site could be there to start to use and perform the dirty, dull, and the dangerous tasks, things that you don't necessarily want to have humans doing, but robots are perfectly situated for taking those tasks over. And then the overall goal of by bringing these types of robots to the job site is that it improves the overall safety, the quality, and the construction process. And so we're really focused around using robotics to address these types of challenges on the job site. Your very common thing that is happening out in the construction market today, labor shortages. Finding talented staff that can come out and do construction or want to be in the construction industry. Safety concerns, not necessarily putting people in harm's way, but having to address the issues that are happening on job sites. The cost of real-time data, being able to monitor things on a job site consistently over time could be very expensive, but there's a lot of value that comes out of that data that could be captured over time. And then having a turnkey solution that really starts to support these kind of monitoring workflows using robotics. And that's really where robotics can really take place and take over these types of problems for customers. It's focused around with labor shortages. By using robots, you can let those take over the kind of redundant tasks, the unsafe tasks. Let the people on site really focus on the high value tasks on the job site. With safety, robots can go anywhere. You can send it into enclosed and confined spaces. Dangerous situations where you need to go in and monitor what's going on, but you don't necessarily want to send people in. Robots are ideally situated for that application. And then, the cost of real-time data and turnkey solutions, frequent data capture over time really starts to provide benefits where you start to compare what's being done in a virtual environment with what's being installed in the physical environment. You can start to identify issues before they actually become issues out in the virtual or the real world application. So with robotics, when we first started bringing this into the construction industry, we were focused around creating this kind of automated data collection workflow, letting the robots to come out and really start to have a route to where they can go on the job site, be able to capture data consistently over time, and as that data gets captured, being able to share it out with the larger project stakeholders. And this is really where we focused around the application that is being used by Mace Group. And so the way that the product actually works is that you come out and you first teach the robot where can it go on the job site, where can it capture data and be able to capture that data consistently over time. And so it starts by having a person come out and teaching the robot where it's safe to operate. One thing with autonomous robots is that they aren't going to go somewhere that you haven't told them that they can go. So a lot of times I get a question from people saying, is this robot just going to randomly go anywhere it wants to on the job site? And the answer is no. If I haven't told it that it's safe to go to this particular location, it will not go to that location. And so part of using the robots on the site is teaching it where it's safe to go, and then as you define this kind of path that it's going to be taking across the job site, you can then teach it where it needs to go and capture data consistently over time. And then once you have that information captured, then you can start to run autonomous missions where the robots can capture the data as many times as you want across the course of the project. So from start to finish, you're capturing data consistently over time, and that data then starts to be able to be used for data analysis to really provide new insights into how the project is tracking from start to finish. And that really starts to support the second half of using robotics on a job site from a workflow perspective, and that's design validation workflow. As you start to get data captured consistently over time, how do you start to get some value out of that data? How do you start to get analysis out of this? And that's really where the second half of the workflow starts to focus on, where it starts with the data transfer, taking the information from the field, putting it to a cloud collaboration platform, And then from there, starting to do analysis that then provides insights to the project teams to where they can make actionable decisions on what needs to be done for the project. And so as the data gets captured and it gets completed at the end of a mission, you have the ability to work with the data in the field to start to get actionable results right there in real time. So being able to do very quick surface analysis types of information, scan to model comparisons, being able to get information before it actually gets moved on to the next process, to be able to make some actionable insights while you're still capturing the data out in the field. And then the last part of it is then to get more robust analysis into the data, really taking it back into the office and starting to gather meaning out of it. So using desktop application softwares that start to work with the scan data and start to drive analysis with it, doing scan to model comparisons, which is what you're seeing with the animation. We're starting to see what has changed over time on the project. So you can start to take scans and compare it against scans that are captured at a different point in time. And by color coding the point cloud that's being captured, you can start to see where change has happened over time on the project. And then from that, you can start to then share it out to a larger stakeholder. And so this was kind of the overall product that we brought out to the marketplace when we first talked about things with Boston Dynamics. And we began to do what's called the Early Experience Program. And that's where we began to partner with companies like Mace Group to be able to start to take this data and start to really work with it in the construction environment to see how can you bring this out to the construction market and be able to use it to start to gather meaning, get actionable insights from the data, and really start to incorporate it as part of a day-to-day workflow. And so to speak about that, I want to bring up to the podium here Kieran Heffernan from Mace Group, who became one of our very first partners from the customer perspective to really start using construction robotics out in the field. So, Kieran?
Hi everybody, my name is Kieran Heffernan, as Dave said. I'm an associate director with the Mace Group in our Dublin office, predominantly on our DC hyperscale project over in Clonee. Day-to-day role is pre-construction, but as a sideline, a lead on as an innovation lead for our business unit, the technology and manufacturing business unit. David quite rightly and expertly explained the vision behind Spot initially from their perspective, but I think it's really kind of unusual the way that we aligned on our visions in regards to what we wanted when we first started actually looking at Spot originally, and then when the partnership came between Boston Dynamics and Trimble, moving in forward into that kind of that next phase. So I suppose what we wanted to talk to and run through today as our case study is our canine friends, Setanta and Dave. This journey started a long time ago. It started even before I think Boston Dynamics and yourselves teamed up. I suppose we made contact back in like 2019, and it was a bit of a journey to try and get ourselves into a place where we were comfortable to move forward with the technology on site and basically make sure that it aligned with our vision. Our vision really was take what is a relatively manual, resource-soaked process of capturing laser scan data in the field, transferring that into the office, and then manually inspecting that laser scan data against your construction BIM model. We wanted to take that as a full life cycle approach into the automated environment. And for us, I suppose the crux of it is we need to understand and gain an ability of automated capture of laser scans in the field that we're comfortable with and we're confident on, that it can actually be actioned on projects moving forward. So Setanta and Dave started their experience with us last year. Setanta, our Celtic Wolfhound, was placed on our hyperscale data center in Dublin, and was, I suppose, the way that we could utilize the robot in a large-scale new build environment. And then Dave, his compatriot, was the canine that we released onto our Heathrow project. Heathrow being a different type of beast, highly complex operational space, had to deal with live environment conditions, so we wanted to test out the capability of the robot in those two scenarios. As you can see, the vision, very similar. We wanted full autonomy. We wanted to enhance our ability to capture laser scan data, not just quality, but quantity. We wanted to be able to gain more access to data regularly, with the vision that we will need that extra layer of data and extra quantity of data when it goes into the realm of progress updates from a time and cost perspective, which is ultimately where our vision is. The QA/QC reviews is the added benefit to what we see as our baseline. Our baseline for Setanta and Dave is to be out in the field capturing the laser scan data that enables us to set up our digital twin as-built model that is required for the majority of our clients that we have on our projects. The QA/QC element is the added benefit. We can use that data midstream, live on the job, to be able to undertake the analysis that Dave kind of showcased to you with the use of Cloud Engine, to relay that information to our trade packages and our trades and our trade contractors and our own construction managers to be able to mitigate and remove any difficult defects that we see live in as a part of the analysis on a day-to-day basis. This is just a showcase of some of the partners that we had. I suppose it's amazing when you start on a journey like this, the relationships that you develop. Trimble, Building Point, Corrick, ECC, Boston Dynamics have been great partners as a part of this trial, this initial phase. Difficult at times, roadblocks and humps in the road that we had to get over, but it was actually those difficult conversations and problems that we faced has actually ended up coming out on the opposite side with a product that we're now confident with because we've teamed up with yourselves. So what did we do, or what were the considerations we wanted to test both of the robots out? Legal perspectives. What are the legal considerations as general contractors do we need to take into consideration as we release autonomous robotics out in the field? What is the best method to procure and manage an asset like this for large GCs? IT and data, this is probably one of the more complex ones actually once we started to uncover that, not just from how we manage the laser scans, how we get that from the robot into the environment, into the office to be analysed. It's also how do we make sure that we're in compliance from a GDPR, a data protection perspective, and also huge quantities of data being generated needs a home, and understanding what is your cloud requirements, what is your on-site storage requirements for that information, and how do you manage that as a part of a project lifecycle from start to finish. And then obviously the handover to the client when it gets to that point. Health and safety. Obviously there's benefits to having Setanta out in the field with certain different types of technology to be able to uncover potential health and safety issues, but also having an autonomous robot in the field is potentially a health and safety issue in itself. And we wanted to make sure that we do an initial risk assessment, but also put in guidelines as to how to operate Setanta and Dave in the best way possible. Needs to be flexible depending on your project conditions and the environment that you're operating the robot in, but that's another element that we brought into the mix. Security, and we'll showcase later on in the slide deck how we went from transporting the robot to the site from the office every day to coming up with a solution, we're calling it the doghouse, that we could have a secure location on site that serves multiple purposes. Obviously storage, security, keeping all the equipment safe, but also using that location, that box scenario, as the point where Setanta or Dave would actually leave and start their work, basically, once they get into their missions. Logistics, that's kind of similar to the doghouse, but also logistics and how you want to operate the robotics in the field. Depending on the size and scale of your job, the battery pack and the size of the missions dictates exactly how much space you can cover at any one time, which means that you need to have almost hub positions depending on the size and scale of your project as to where you want to base the home location of Spot, and then transfer it on a nightly or a daily basis to different locations, depending on the size and scale of your job and where you need the laser scans to be undertaken at the most. And then digital integration. We're all working on a day-to-day basis these days of trying to understand how we can capture the information that we're generating across all of our different platforms into a sole location. Everybody's talking about digital command rooms or mission hubs, but being able to uncover and release the data from Spot into that process to make sure that we're combining it with other aspects of what we're doing in the field. An initial desktop study. Dave did this for us right from the right at the original time. This was our goal. This was our aim to test out the Spot Robotics. Is can it actually cover this quantity of space over this duration of time? The answer is no, but it covers a nice chunk of space. I think for us, maxing out on a 100 scan mission, you're talking about 3,600 square meters of scanned space on one 100 scan mission. I'll go into a bit of detail on what that means, but we started out on 5 scan missions, 10, 20, and as we progressed through the trial that we undertook, we got ourselves to the capability that we were seeing a 10-hour fully autonomous 100 scan mission being undertaken by Setanta in our Dublin site, which I believe was first of the world, and I don't know if hopefully nobody else has gotten to that level, and we're still at the top of the totem pole. But that was a world first, I think, and it was a great achievement for the team. This is just a bit of a kind of a time slice on the key stages of the trial that was undertaken for Setanta, and Dave also undertook a very similar process. So this is a roadmap kind of a scenario. So we kind of ended up at the very start. I might just actually go out into the room. So this was the initial 2 phases. So we had team familiarization and training, which is basically ramping up our digital capable staff that we had on the site, ramping up their knowledge on how to actually use the software that accompanies the hardware. The hardware is actually the easy part. It's making sure that people are trained up in the operation of the software that controls Spot and controls the X7 laser scanner on its back. Then we started going into the formulation of our route plans. How far can we travel across within the I suppose the building that we were operating in? Started out small, gradually built on that, expanded the type of routes that we were undertaking. And then once we were relatively comfortable with our route setup, we started just undertaking missions. Started small, and then gradually got up to the point where around July of last year, that was when we first succeeded that 100 scan mission, 10 hours, fully autonomous. I think 3 or 4 periods during that 10 hours, Setanta automatically went back to its docking station, charged itself, went back out to where it left off, and then continued on the route. And then we got the full data pack, which at the end of that, which then we were able to transfer over to our BIM team. Multiple visits from the Boston and Trimble team during the whole course kind of allowed us to course correct wherever we were seeing or experiencing issues in the trial. We were able to relay that to the team. And I think around March of last year or May of last year, we decided to go into the realm of testing out the beta software that you guys were developing so that we could work out the chinks in the armor, give you that feedback, and then by the time the next cycle or the next rev up of that software was available, we were seeing there was a step change in the performance of Spot, which was fantastic. It kind of gave us an impetus to continue on with what we were doing because we could see improvements were being made. For us, training is key. The operation of Setanta and Dave is really about bringing on people that are existing within our construction teams in the operation of it. It's a highly intense setup period at the start of your job. It's really based on the amount of missions, the amount of floor space you have across your entire project, internal and obviously external routes as well. So it is intense to set up the missions at the start of the project and at key phases, but once you have a mission set up, it's literally click of a button from that point onwards, and that's what we've been experiencing, which is great. Yes, there is time input, there is commitment that needs to be made, but it's amazing when you see the amount of times that he can just go off and just do his thing, comes back on site, we get that feedback data. It's fantastic. At the latter portions of the trial, we started looking at the design of a doghouse, which was a secure location that provided easy logistical transportation of not just the robot itself, but its charging dock, all of its spare equipment, the laser scanner, and all the equipment that comes with that. And there's a quick photograph of what that looks like. And basically from September of last year onwards, right through to now, we're kind of in a phase of going through an internal review as a business as to how we take the information that we've gained from the trial to set ourselves up right for the future, undertaking the proper due diligence as a business to make sure that the robotics is the right way to go forward, and this package is the right way to go forward, and that's where we're currently at right now. So yeah, world first fully autonomous 100 scan mission, 10-hour fully autonomous self-charging with no human interaction, and that covered approximately 3,600 square meters. We have over 30 individual missions recorded, and that's just based on the trial data and the project that we were basing it on between Setanta and Dave. And then you've got individual scans. You're plus in the 100. You're well in the hundreds at this stage in regards to the individual points we've recorded. Hundreds of kilometers of travel time, and I suppose in total we've definitely over about 60,000 square meters of scanned space now completed as a part of the trial phase. That's just an image of the custom manufactured doghouse that we manufactured. That's the front door that obviously pops out, storage capability, and we use it also as the set out location for Setanta for when it takes off from its station, it returns back to that location, and that's tied in with the BIM model as well, so it aids our coordination of all our BIM models, so it's aligned with the construction model. Looking at obviously developing an operational guideline as well, so that for us, this is a trial to make sure that the greater business can gain from that, learn from it, and utilize information and that guidance on future projects. It's scalable. It's not just suitable for larger scale projects. It really depends on how you operate laser scanning against BIM modeling. And I think that's it. So, probably one of the most important part was, the team collaboration is probably the biggest thing when we took on this trial. It needed commitment, it needed people that had digital capability, and it also needed people that had a desire to actually make it work. We came across some issues and a couple of hurdles that we needed to jump, so we needed to take that kind of open mindset that this is a journey with a vision. The vision's still in the distance, still a long way to go, but we've made some great progress. It needs a resilient focus, and really kind of going down this adventure really has started to break boundaries that I think is only going to prove to be beneficial for us in the long run. That's it just from our case study perspective. Right out to the very end. Questions if anybody has them. Yeah? It's just a microphone.
Hello.
Hi.
So while implementing the Spot robot into your scanning, so it's basically like the inspection which you are doing. So did you face any challenges or limitation that you feel of Spot robot, which the Boston Dynamics needs to overcome more?
Yeah, absolutely. You might want to jump in here, Dave, as well. So, original limitations were self-charging, and then taking off from that point onwards. When we first started in March of last year, it was 20 scans max, come back to the station. That was the end of your mission. But working with the team in the months after that, we're now at the point where Setanta and Dave have the capability of self-charging themselves. It's literally a function now that's available in the system that wasn't at the start of the trial, so you can input that self-charge point. You also need to know your robot, and you need to understand that the battery pack, the grid spacings of where you actually you undertake your scans. So normally it's like a 6 meter grid system, so that when that self-registration of those scans is undertaken at the end of a mission, they all self-register correctly. We've experienced on a wider grid, you get more breaks in that self-registration, which you have to manually go back in and fix. But again, I suppose the performance has increased all the way through to even where we are now, and further hopefully into the future.
Yeah. And one limitation of Spot robot was that
Can I just hold?
One limitation of Spot robot was it cannot overcome all the obstacles. For example, it can go on terrains, but it cannot open the door for you if it's closed. So it's on the mapping which is there, and it depends upon human to still operate it. It doesn't.
So right now, it does depend on a human being to set up a mission once. But once you have that mission set up, it's completely automated from that point onwards. In regards to doors, every project has doors, but normally they're not installed into the latter stages. So you've got a clear space of kind of empty space to run through and manage your robot routes until the point that it comes close to the end of the job. That is something that needs to be managed by the construction teams, there's no doubt about it. I don't believe we have the capability of putting the arm on the back of the robot at the moment with the laser scan mounted, so that might be a challenge for another day.
Yeah.
But all the way through, we've uncovered difficulties in regards to setting up the scan routes that as a collaborative team we've been able to uncover solutions for, if that makes sense.
And one last thing. What is the AI integration with the Spot robot? The artificial intelligence integration with the Spot robot?
I think Dave might be the best person to...
So that's part of what's starting to be researched now as part of taking that data and getting value out of it. So some of the different products that are out there are starting to read like the scan data to be able to compare it against databases of models for different types of manufacturers. A lot of the work is being done around 360 imagery to be able to read the images and start to update a construction schedule. So that's really kind of where the emerging part of the technology really is now. Our initial focus was on the automated data collection out in the field, and that's really what we worked very closely with Mace around. And then now we're shifting that focus to then start to incorporate more of the AI applications. And so we have different companies that we're starting to partner with to focus on that, but still very early on in those applications.
So while you all were successfully, you all have done 100 experiments of scans altogether, like in one sequence. You all were able to do 10 hours of scan. So all the data which was collected by the Spot robot, so was it a single file, or every time it goes to charge and come back, there's one more file? Single file. All
Single
collaborated
file.
together.
Yeah.
Thank you.
Yeah.
Why did you favor the canine design? Because you do have bipedal robots. Would it not be more advantageous to use those instead to collect your data?
Sorry, I didn't hear all
catch
that.
the first part of that.
Why did you choose and favor the canine design, the dog design, rather than a bipedal robot?
I see, yeah. Legged robots give you the most flexibility for different terrains that you're going to be going over. There are different applications where like a wheeled robot makes more sense. But in these applications, for the variety of different changes and things that happen on the job site, we really felt partnering up with Boston Dynamics and having a legged robot really gave us the greatest flexibility for the different changing conditions on a job site. So with the robot, we can go over, not just having perfectly smooth concrete decks, but if there is pan decking, rebar, loose gravel, stairs, we can go up and down and go through all those different changing environments, indoor and outdoor. So it just gives us more flexibility.
Could you not have done that with a bipedal robot, a humanoid robot?
That's got a ways to go. Boston Dynamics does have their Atlas robot that you see, doing all the flips and tricks and things like that. Still has a way to go before that one actually becomes available for the market. But eventually, yes, you will see those types of robots, come out and take on those type of capabilities, similar to what Spot's doing right now, but using 4 legs.
Thank you.
Time for one more. Yeah? That one there? Yeah?
Hi. When you were doing the scans in the tunnel, how effective was it at knowing where it was without any GPS signal to locate each scan relative to each other?
It's a really good question, and it actually was one of the main questions I had when I started out. I am actually a member of the team for the Setanta team, so I don't exactly know on the tunnel, but it's the same technology. But Dave, you're probably better as to the geolocation.
Yeah, a lot of the scanning gets done where it registers in real time on the robot itself, and it's just registering it relative to each other. So it's kind of in that kind of relative space, and then after the fact is when most project teams are then georeferencing it back to coordinates. So if there's targets set up in the tunnel situation, they'll get those scanned and then they come back and they reference it after the fact. But there is the capability at the beginning of the scan, the laser scanner that's used on top of Spot does have the ability to do a resection. So if you have known control points, you can shoot in the control before you start scanning, so that then those scans do drop in within the coordinate system. But most people have found that it's more faster and more efficient just to capture the data, have the targets registered, but then come back after the fact, and then in the desktop software do that georeferencing.
Yeah, just do post-processing.
Post-process, yeah.
Just to add to that, that's one experience that we had. The data center development that we had, Setanta trialed in, huge long corridors, white wall both sides, and quite often it was the case that it actually got lost. We actually came up with a strategy at every turning point on the corridor, and at every 10-meter point you've got your QR code and fiducials.
Yeah.
So it was able to actually recognize the position it was in until it actually got home. So that was one solution that we came up with. Doesn't like shiny objects.
Thank you very much.
Yeah. I think that's it. Thanks
right.
very much, everybody.
Thanks for your time. Enjoy the rest of the conference.